Hi, welcome to the exercise of BIO 1026 Chemistry 5. Today we will do the exercise of lecture 5, basically carboxylic acid. Okay, the first exercise is to say which is the functionality of the following compounds. We have these compounds. Okay. This is a carboxylic acid. Okay. This that presents a carboxyl group and an amine is called amide. This that has a carboxylic and an alcohol is called ester. And this one that has a carboxylic functional group and a chloride is called acid chloride. Okay? That has been easy. Now we will start with the exercise number 2, where we will do write the mechanism for the following reactions. We have this compound. And we add ammonia in excess. Okay? If we don't say anything, means that we are in basic media. If we were in acid media, what we will do is to put protons, but in this case there are no protons. That means that we are in basic media. And basically what we have is that the ammonia, the pair of electrons of the nitrogen, are attacking the carboxylic group, and then first step, addition. We generate the tetrahedral intermediate, remember. Next, we eliminate the proton, and we have okay, and now is taking place elimination. We form again the carbon-oxygen double bond, and the leaving group is departing to form the final amide. Okay? Remember that always is addition, elimination mechanisms, okay, with a tetrahedral intermediate. This will be always a mechanism for this type of reactions. Right? Okay. Second one. We have this amide and we add sulfuric acid in water. Okay, that means that what we add is acid in water. First step always that we add acid in a reaction will be the protonation. Okay, the pair of electrons of the oxygen is taking off the proton, and what we have, this always is the first step in acid media. We generate this compound. Why? Because we want to activate this position. Now, what we have is that the nucleophile, in this case the water, half electron of the oxygen is attacking here. Why? This is a weak nucleophile, but now we are activated this carbon. This carbon is more electrophilic because we protonate the carbonyl group. And what we have is this is addition. Okay, we have this intermediate. This is the tetrahedral intermediate. Okay, we remove a proton. And now in the next step, we protonate the leaving group. That basically has to be the nitrogen, okay, the amide. And what we have is this intermediate. Now this is ammonia, that is a very good leaving group. This is leaving. We regenerate the carbon-oxygen double bond. What we have is okay, and then we lose a proton to get the final carboxylic acid. Remember that in almost all the reactions, the final compound is always a neutral species. Okay? Right? Always addition, tetrahedral intermediate, and elimination. Okay? Always is this the mechanisms. Addition, we get the tetrahedral intermediate, elimination. Next one. Why this reaction didn't take place? We have here a carboxylic acid. We treated this with methoxide. Okay? Why this reaction didn't take place? But what we could expect is like this: attacks the carbonyl group, addition, elimination, and what we get is this: the formation of the ester. But this reaction will not take place. Why? Why this is not happening? Because here we have a carboxylic acid. This proton is a highly acidic proton, isn't it? And here we have a base. That means that the first reaction that will happen is an acid base, and what we will generate is the carboxylate. And remember that the carboxylate is, this carbon is not anymore electrophilic. This is stabilized by this resonance species, and this is not electrophilic. Okay? This is the reason why this reaction, not the reaction of the formation of the esters, didn't take place. Okay? Good. Next exercise basically is to fill the gaps. Okay? We create this with base, and what is indicating this group, this exercise, is that it's as acid base. That means that what is happening is that what we get is this will take this hydrogen and we will form this anion. Okay, that we can grow the resonance structure basically will be this. Okay, next one we have okay, and this time they say that it's a amide formation. That means that basically what will happen is that the pair of electrons of the nitrogen will attack the carbonyl, addition, elimination. I am not doing all the mechanisms. You can do it at home, it's a very good exercise. And what we will get is the amide. Next one, we have this compound. And we treat this with water in basic media. Okay, they say that it's a hydrolysis. What will happen is that basically the hydroxide will attack, addition, elimination, and what we get is the carboxylic acid. Okay. Next one. What we have is okay, carboxylic acid. We add methanol with protons. Here we have an amine. Here we have an amide hydrolysis. Okay? Okay, this is an acid. We treated with in acid media with an alcohol. What we will get is the ester. Remember, we protonate first the carboxyl compound. Here we protonate this oxygen, making this carbon more electrophile, and then the methanol will attack. We protonate the wedge in order to make a very good leaving group. It's departing, and we get the final product that will be it at home. Okay, second one, we add this secondary amine. What happens is that the pair of electrons will attack here. We are in basic media, addition, elimination, and what we generate is the amide. And finally, the amide hydrolysis, we can do it in acid media or in basic media. I recommend to do it in basic media. Heating, and what we generate is the hydrolysis of the amide to obtain the carboxylic acid. Okay? Next exercise. Tell us what are the products of the reactions shown below. We have here an ester. We add a secondary amine, again, addition, elimination, and what we get is this final amide. Please do it at home and check that, do at home the mechanisms and check that the final product is what I draw. Here we have the same compound, but now we are treating with sodium hydroxide in water. Okay, again it's basic media. That means that the OH will attack here, addition, tetrahedral intermediate elimination, and what we will get is the carboxylic acid, that because we are in basic media, we generate the carboxylate. And finally, we have this triglyceride. We have this triglyceride. Okay, I put R here in order to save time. Okay, we treat this with a lipase in water, and the only that we need to remember is what is a lipase. Lipase is an enzyme that basically is breaking the ester bonds during a hydrolysis. That means that what we will get is free fatty acids, free acids, plus the cryo. Okay? And the last one, okay? Please do the mechanism for all the reactions. It's a very good exercise for you. It's quite repetitive. This is why I am not doing it here, but it's a very good exercise for you to do it at home. The next exercise is give the reaction products of the following reactions. Okay, we have here an ester, and we add a primary amine. Basically what we will get, again we are in basic media, addition, elimination, and what we get is the formation of the amide. Oops. plus methanol, that will be the other byproduct. Next one is this. We have this compound. We add exactly the same amine. Sorry. Dimethyl. Okay? Basically it's the same. Addition, regeneration of the double bond, elimination, and what we get is this compound plus because it's not aromatic, it's okay. Next one we have this benzyl. And we add secondary amine, exactly the same. Addition, elimination, and what we get is damide plus methanol next one is basically here we have this cyclic ester, okay, and we add sodium hydroxide in water. What will happen? Well, the same than before. The hydroxide, we are in basic media, will attack addition, elimination, and what we have is negative charge, and this will become decarboxylate, because obviously this hydrogen is by far more acidic than not the alcohol, and if I am not wrong, we will get this final product. Next one we have here this ester, we add acid, water. Basically what we will have is the addition, first protonation of the ester, okay, addition of the water, elimination of the benzylic alcohol, and what we will get is the acid plus benzylic alcohol. Okay, these are all the exercises. The last exercise is very difficult to do it in the whiteboard, but in the PDF that I will add in Blackboard, you will have the answer. Okay? Thank you for your attention, and see you soon in the next lecture.